Hi everybody, so today we are looking at the empirical formulas again, and this is 2018 question 4i we're specifically looking at. Now this is actually a little bit trickier than most empirical formulas. Well, it looked a little bit trickier, but in actual fact it was pretty much the exact same, but students were put off by it nonetheless. So first off, they were given a name that they've never heard of before, okay, an antifreeze and so forth, okay, doesn't matter, okay. You're asked to find out the empirical formula, and you could be asked to find out the empirical formula of any formula that you've never seen before, or any name you haven't seen before. Let's just go down to what we actually have, the heart of it. And we're told it's 54.5% carbon, 9.1% hydrogen, and 36.4% oxygen by mass. Okay, so all we're going to do there is, guys, is we're going to split that up, and we'll start off with carbon. So carbon here, and we'll do what we normally do for these. Okay, we're going to calculate the number of moles. So number of moles equals mass over mol. Now, if you look at your periodic tables for carbon, okay, you'll see for carbon there that the mol of carbon is 12. The mass, 54.5% here, so we're going to assume that's 54.5 grams. Okay, any of these, you just assume that they're going to be in terms of grams. Now, if you divide that by 12, you're going to get 4.54 moles of carbon. So put a little box around that, and now we're going to solve for the rest of them. That's carbon. Let's do hydrogen next. Hydrogen. So we're looking for number of moles again. So our number of moles is mass over mol. So our mass in this case here is going to be 9.1 grams over the mol of hydrogen. So that's just 1. Okay, so 9.1 divided by 1 obviously is going to be 9.1 moles of hydrogen. And we put a little box around that. Grand. Next, oxygen. Find out your number of moles. Mass over mol. So our mol of oxygen is 16, and the mass is 36.4. And if you do that into your calculator there, you get 2.275. Okay, now find out which is the, this is oxygen, just to clarify that. Moles oxygen, put a box around it, and next we're going to find out which is the smallest value. And we can kind of see straight off that oxygen is actually the smallest value there. Okay, so we're going to write it down here, and it doesn't matter what order you write it in. I'm just going to do it in the way it has up there. So that's carbon, hydrogen, oxygen. Okay, so oxygen is going to be 1 because it's that smallest value. How many times does oxygen go into carbon? We'll start off with that. Okay, so 4.54 divided by 2.275, and if you do that out, you only get 1.99. So can we assume there, guys, that's going to be a 2? So we put a 2 down here. Next, how many times does it go into 9.1? So 9.1 divided by 2.275, and that equals 4. So we have 4 hydrogens. And that's our answer, guys. And you can see that it actually wasn't much different to what we've been doing before. It was just that at the very beginning you were given something that you really had not seen before, and you would never have seen it before. And percentages, and students just said, oh no, can't do this. But in actual fact, it's the same as we've always been doing. Getting the number of moles, whichever is the smallest one, that's going to be our 1, and dividing that into the rest of them to find out the ratio of that. So look, I hope those help, guys, and all the best with them.